Hey guys, it's Sukrit from STEM Coder, and today we will be going over another matrix operation, the transpose. When we take the transpose of a matrix denoted by the superscript T, we are in essence switching the rows and the columns. So basically, we take the transpose, row 1 becomes column 1, row 2 becomes column 2, so on and so forth. We got this matrix A, B, C, D, and E, F. The first row, AB, becomes the first column, AB. The second row, CD, becomes the second column, CD. Third row, EF, becomes third column, EF. You may also notice that if our rows become our columns, then our columns become our rows. So we got this column, the first column is ACE, well that becomes our first row, ACE. So yes, we're switching the rows and the columns, vice versa. Let's take the transpose of an example. We have 1, 3, 6, negative 2. Well, once again we've got 2. Switch the rows and the columns. Our first row is 1, 3, that becomes our first column. Our second row, 6, negative 2, second column, 6, negative 2. You also notice that our first column became our first row, second column our second row. Our first row became our first column, and our second row became our second column. Go ahead and pause the video and try taking the transpose of this matrix. Once again, we've got to switch the rows and the columns. First column is 2, 1, 0, that becomes 2, 1, 0. Our second column, 0, 1 half, negative 3. Second row, 0, 1 half, negative 3. Voila, we got our transpose. We notice that because we are switching the rows and the columns, we are also switching the dimensions. So if I start out with a 3 by 2 matrix, so 3 rows and 2 columns, I end up with a 2 by 3 matrix after I take the transpose. Same thing. Here I have a 3 by 2, I end up with a 2 by 3. Here I have a 2 by 2 and I end up with a 2 by 2. It's a square matrix, so my dimensions don't change. It's important to note that we have a special type of matrix called the symmetric matrix. And it's defined by, if I have a matrix A and I take its transpose, I should get back that same matrix A. This matrix over here, 1, 0, 0, 1, if I take its transpose, first row becomes first column, second column becomes second row, sorry, first column, first row, second column, second row. You can clearly see that you end up with the same matrix after taking the transpose. So also this matrix over here, you can kind of see that the values across that diagonal are reflected. 1, 1, 0, 0, 9, 9. And if I take the transpose of this matrix, I end up with the original. You can kind of think of taking the transpose as drawing this imaginary line through the matrix, this diagonal line like this, and basically flipping the matrix across the diagonal line. So when I flip the matrix like this, that's why my rows become my columns and my columns become my rows. And naturally, if across this imaginary line, if I have the same value, so like 1, 1, 0, 0, 9, 9, well then if I take its transpose, logically I should end up with the same matrix. I hope you found this video helpful, and I look forward to seeing you in future videos.